Notice how the parallel rays converge after reflection. This is where we find the real and inverted image, the focal point of the concave mirror.
Guru Brahma, Guru Vishnu, Guru Devo Maheshwara, Guru Sakshat Parabrahma, Tasmai Shri Gurave Namaha.
Hello, students, and welcome back to the fascinating world of optics. So, we've talked about mirrors, but today we're going to turn our focus, pun intended, to how light behaves when it passes through something. Spherical lenses. We're going to get a handle on the different types of lenses, how they form images, and the super useful ray diagrams that let us predict everything.
I mean, really think about it. How does a simple piece of glass make things bigger? Or how do your glasses help you see clearly? Well, it all comes down to one amazing principle: refraction. That's just the bending of light. And lenses, well, they're the masters of refraction. So let's dive in and see how they do it.
All right, here's our game plan. We'll start with what these things even are. Then we'll meet the two main players, converging and diverging lenses. We'll get the three simple rules that light follows, see them in action, forming images, and then, wrap it all up with why any of this matters.
Okay, first things first. Let's get a really solid definition of what we're talking about here.
So a lens is basically just a piece of see-through stuff, like glass, that has at least one curved surface. And that curve, that spherical shape, is the whole secret. That's what gives a lens its incredible power to bend light in very specific, predictable ways.
Now, when it comes to lenses, there are really two main types, and they do completely opposite things to light. You can almost think of them as two characters in a story, each with a totally different personality.
First up, we've got the convex lens. This is our converging lens. You'll always know it because it's chubby in the middle and gets thinner at the edges. Its whole job is to take parallel rays of light and bring them all together, focusing them into one single powerful point.
And then you have its opposite, the concave or diverging lens. This one's skinny in the middle and thicker at the edges. And yeah, it does the exact opposite thing. It takes those same parallel rays of light and just spreads them out, making them diverge away from each other. So when you see them side by side, it's super clear, right? One is thick in the middle, the other is thin. One brings light together, the other spreads it apart. The entire difference in what they do comes right down to that simple change in shape.
Now, here's a really important detail. Remember how mirrors had one focal point? Well, lenses have two, one on each side. We call the dead center of the lens the optical center, or O. And the distance from that center point to the focus? That's the focal length. It's kind of like the lens's magic number.
So, how in the world can we figure out where a lens is going to form an image? We don't have to guess. Turns out there's a simple little toolkit, 3 rules that light pretty much always follows. Let's check them out. These are our 3 go-to rays. And here's the best part, you don't even need all 3. To find exactly where an image is going to show up, you just need to draw the paths of any 2 of these. Where they cross, bam, that's where your image is.
Okay, rule number 1, the parallel ray. If a ray of light comes in straight and parallel to the main axis, a convex lens will bend it right through the focus point on the far side. But a concave lens? It'll bend the ray outward, making it look like it came from the focus point on the same side. Now, rule 2 is basically just rule 1 in reverse. It's so elegant. If a ray of light goes through the focus point before it hits the lens, it'll shoot out the other side perfectly parallel to the axis. See that symmetry? It's awesome. And finally, we have the easiest rule of them all. Rule 3. Any ray of light that goes smack dab through the optical center, the very middle of the lens, just keeps on going. No bending, no turning. Straight through. Easy peasy. All right, now that we have our 3 rules, we can finally put them to work. Let's see what kind of images these convex and concave lenses can actually make. And wow, just look at this table. It really shows you how incredibly versatile a convex lens is. I mean, depending on where you put the object, you can get a tiny image, a same-sized image, or a huge image. It can be upside down or right side up. It's like the chameleon of the optical world. But let's zoom in on this one special case right here. If you bring an object super close to a convex lens, closer than its focal point,
something really cool happens. The image flips upright, and it gets bigger. And that right there is exactly how a magnifying glass works.
Now, compared to that versatile convex lens, the concave lens is, well, it's simple. It's incredibly consistent. It has one move, and it does it every single time. It doesn't matter where you put the object, a concave lens will always give you a virtual, upright, and smaller image.
Okay, that was a lot, but it's all super important. So let's just take a breath and boil it all down to the key takeaways.
So here's what you really need to remember. Lenses work by bending light. That's refraction. Convex lenses bring light together, they converge, and can make all sorts of images. Concave lenses spread light out, they diverge, and always make small virtual images. And those three rules, they're your secret weapon to predict what any lens will do. And that just about wraps up our look at these rigid glass lenses, but it leaves us with a really cool question, doesn't it? We've figured out how glass works, but what about the lens inside your own eye? It's flexible. How does it manage to do this same job, focusing on things both right in front of your face and miles away? Well, that's a story for next time.